Thank you for always joining us. We are looking at KCSE 1995 paper 2 question number 20, a question on trigonometry. And the question reads, a hillside is in form of a plane inclined at an angle of 30 degrees to the horizontal. A straight line road 800 meters long lies along the line of the greatest slope from a point A to a point B further up the hillside. If a vehicle moves from a point A to B, what vertical height does it rise? For us to work out this question well, a learner is supposed to know how to do the sketch. We have already done the sketch where we have point AB, which is the length of the road, 800 meters. If I say this is a point O, then OB is going to be our vertical height. Given the angle theta, which is 30 degrees, and the hypotenuse, which is 800, we use Okatoa, where we are going to use sine theta, which is sine 30 degrees, being equal to the distance we are looking for is the opposite side, which is h, to divide by the hypotenuse, which is 800. For us to get our height, we multiply both sides by 800, such that our h is going to be 800 multiplied by sine of 30 degrees. Sine 30 is 0.5 times 800, giving us exactly 400 meters as the vertical height through which the vehicle rises. We move to point or part B, and part B says D is another point on the hillside and is on the same height as B. As you can see, this is our D and this is our B. Another straight line road joins A to D and makes an angle of 60 degrees with AB. This is our 60 degrees, and if this is our 60, this is also our 60 degrees. If this one is 90, then this one is going to be 30 degrees. So if AB is 800, meaning if I drop another point Q here, QD is going also to be 800. From here now we can move and calculate the length of the road AC. Remember, we have also been told that AC is 3/4 of AD. AC is 3/4 of AD. So the first thing we need to calculate is AD. Remember, we have the angle 60, and the adjacent DQ with this angle, which is 800. Getting AD becomes very, very easy. We are going to move as follows. We are going to use the cosine of an angle, that is cos 60 is given by the adjacent, and the adjacent is QD. You divide by the hypotenuse, which is AD. In this case, to get AD, you simply take QD, which is 800, you divide by the cos 60, and this one is going to give us 800 divided by cos 60. Cos 60 is 0.5, so we are going to have 800 over 0.5, and this one gives us 1600 meters. If AD is 1600 meters, then AC is going to be 3/4 of 1600, and this one gives us 1200 meters. And by so doing, again, we have done part B. I think this is part B, Roman 1. Then B Roman 2, we are supposed to calculate the distance CB. We have the distance C, and this is where we have B. This one is now going to be very easy since we have all what we are looking for. And for us to get the distance CB, we are going to use triangle A. We are going to use triangle AB using triangle AB. B, we are going to use A, B, and C. Using triangle ABC, we are going to have a triangle that is looking like this, where we have A here, we have B, and we have C. We already have AC as 1200 meters, AB is 800 meters, and the angle A is 60. Now using cosine rule, we are going to using cosine rule. Remember, what we need is the distance BC, and therefore we need BC squared is going to be equal to the square of the two other sides, which is 800 squared plus 1200 squared minus twice times 800 times 1200, then the cos of angle A, which is 60 degrees. 800 squared plus 1200 squared will give us 80,000 minus 2 times 800. This is 800 here. This is twice times 800 times 1200. So if you take 2 times 800 times 1200 cos of 60, we are going to get 960,000. So BC squared is going to be equivalent to 28,000 minus 960,000, giving us 1120,000. And for us to get BC, we are going to take the square root of 1120,000, and this one is going to give us 1058.3 meters, which is approximately 1058, correct to the nearest whole number. We are through with Roman 2, which is the distance CB. So CB is 800 meters. Now we need to calculate the angle of elevation of BC. This is now very easy. This is very easy. We are going to talk about the bearing, the angle of elevation BC. Angle of elevation BC. We are again going to sketch our diagram as follows. Remember, if OB is 400, then using the ratio that we are given of AC to AD, we are also going to place our point, for example, B prime here, such that B prime is going to be equivalent to 3/4 of 400, which this one gives us 300. So OB1 is going to be 300, and B prime B is going to be 100. In this case now, we can be able to get the angle of elevation here, which is angle theta. We are going to try and now sketch this diagram this way. We have B1B, this is 100, and this is C. B1C is going to be, this is actually 1058.3, and this is our angle theta. So given this hypotenuse and the opposite side, then we will be able to get the angle theta. So using SOHCAHTOA, we say sine of angle theta is given by the adjacent, by the opposite, sorry, which is 100. You divide by 1058.3, and this division here gives us 0.0945. And if you want to get the angle theta, you find the sine inverse of 0.0945, and the sine inverse of this will give us 5.42 degrees as the angle of elevation. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. For consultations and for personalized tuitions, you can contact us on the number 0701 686283, and we shall be glad to lend our assistance.